Everyone, welcome back to my YouTube channel. As you all know that my name is Archita. I am currently pursuing my BE in Sri Venkateshwara College of Engineering, Bangalore. SEM 3rd SEM. My USA number is 1BE23CS008. I am from the branch of CSE AI. The subject we are going to discuss in this video, Mathematics for CSE stream. The subject code is BCS301. The topic we are going to discuss in this video, Introduction to Probability Distribution. Let us see the contents we are going to discuss in this video. Introduction to probability distribution, overview of discrete continuous probability distribution, explanation of key concepts like random variables, probability mass function and probability density function. Let us see the introduction to probability distribution. A probability distribution describes how the probabilities of different possible outcomes are distributed from a random variables. It provides a mathematical function that gives the probabilities of occurrence of different possible outcomes. Probability distributions are essential in statistics and probability theory as they help model real-world scenarios where outcomes are uncertain. Probability distributions are foundational concepts in statistics and data sciences, essential for quantifying uncertainty and variability. They serve multiple integral roles across various fields such as finance, healthcare, and engineering. Within his framework, we can identify discrete and continuous distributions, each tailored to accommodate unique types of data and their respective probabilistic behaviors. Let us see the overview of discrete continuous probability distribution. Probability distribution can be subdivided into two main categories, discrete and continuous. Discrete distributions such as the binomial and Poisson distributions are perfect for modeling events with distinct separate outcomes, while continuous distributions, discrete probability distribution and continuous probability distribution. Discrete probability distribution, a probability distribution for a discrete random variable which takes an countable number of possible outcomes. The example for discrete probability distribution are the outcomes of rolling a die. 1, 2, 3, 4, 5, 6 are discrete as there is a specific set of numbers. Second, continuous probability distribution. A probability distribution for a continuous random variable which can take an infinite number of possible values within a given range. Example for continuous probability distribution are the time taken for a computer to complete a task or the height of a person is continuous as it can take on any value within a range. Let us see the third topic, random variables. Let us see definition and its types. Let us see the definition of random variables. Random variables are functions that map outcomes to numerical values, facilitating the quantification of random phenomena. The types of random variables are discrete versus continuous random variables. Discrete random variables takes on specific values, while continuous ones can take any value within an interval, offering diverse applications. Let us see the importance in probability distributions. They serve as the fundamental building blocks of probability theory, enabling the analysis and mathematical modeling of uncertainty. Let us see random variables. Random variables are pivotal in understanding the probability distributions, acting as a bridge between measurable data and statistical modeling. Discrete random variables yield outcomes, clear-cut outcomes, while continuous ones require more sophisticated approaches to capture the vast array of possibilities. Their significance in probability distributions cannot be underestimated as they are essential for deriving properties and functions that guide analysis. Mass function PML. Let us see the definition, formula, examples, and its importances. Let us see the concept of probability mass function. The probability mass function defines the probability that a discrete random variables equals a specific value, encapsulating the essence of discrete analysis. Mathematical representation, mathematically represented as a p of x equals to x, which quantifies the chance of each specific outcomes occurring. Examples of the probability mass function are examples include flipping a coin, rolling a dice, and analyzing the success rates in trials, showcasing its real world relevance. Let us see the probability mass function properties. By mathematically expressing these probabilities, the probability mass function becomes a powerful tool for analysis in diverse contexts such as game theory or epidemiological studies, where we often explore various discrete outcomes. A probability function that gives the probability that a discrete random variable is exactly equal to some value. For a discrete random variable, the probability mass function is denoted by which tells you a probability of taking the value. Let us see the examples of probability mass function. If a fair door is ruled and the probability of mass function is getting 3. Let us see the probability density function. The definition of probability density function. A probability density function illustrates the relative likelihood of a continuous random variable taking a particular value. The mathematical formula are often expressed as f of x equals. It is crucial for deriving the probabilities over an interval rather than individual outcomes. The integral of the probability density function over a specified interval gives the probability that the random variable falls within the interval, emphasizing its significance. The probabilities for density function properties. A function that describes the likelihood of a continuous random variable to take on a given value. Since the probability of continuous random variable taking as an exact value is 0, we instead use the probability density function to describe the probabilities over an interval. For a continuous random variable, the probability density function is such that the probability that lies between two values and is given by the integral of over. Let us see the conclusion about the probability. Introduction to probability. A conclusion about the probability distribution emphasizes its central role in understanding and modeling randomness. Probability distribution describes the likelihood of different outcomes, a random variable allowing us to quantify the uncertainty and make informed predictions. In conclusion, probability distributions are fundamental in statistical analysis, providing a framework to understand random phenomena and enabling more effective decision making in uncertain environments. Thank you.